All right, now this type of problem and the one after it are much more likely test style questions. So a bag of Reese's Pieces contains 20 orange, well, I like chocolate and peanut butter. 20 orange pieces, 14 brown and 18 yellow. That's funny. Pulling out 6 pieces, what is the probability that ... So by saying what is the probability that, I'm asking for a fraction, decimal, or percentage. We're going to want to be going fraction here because they are the easiest. So I want you to think about numerator and denominator. Because in the previous 2 problems was a cookbook example as far as I led you to the answer as far as, oh, I just had to go back to part A to get part of the answer. Now, rugs pulled from out under you, we have no cookbook. We're going right to the get-go. So in part A, oh, I can't use yellow, that'd be weird. We'll go purple. So tell me in English what the numerator would represent. So start off with the number of ways to get 6 pieces that are yellow. Okay, so let's do this now. How many total yellow pieces are there? Excuse me, 18. Out of those 18, how many do we want? 6. So you would say a combination. Why is it a combination? Yeah. Distinct objects. Even though they're all yellow, we can still consider them distinct. So the numerator, again, in English means the number of ways to get 6 yellow pieces. Denominator, what does this mean in English? The number of ways of getting 6 pieces out of the whole. Good. How many total pieces are in this bag of candy? 52? Is that right? Oh, I have 52. So out of those 52, how many pulling out? 6. All right, what'd you get for the numerator? And the denominator? $520. Okay. That reduces. We're not going to because I don't have that with me. So now notice in the numerator, did we have to talk about the browns or the orange pieces? No, because every piece was accounted for. Of the 6 pieces, they all happen to be yellow. If you want to, you could have also included the brown and the orange because you would have said, out of the 20 orange pieces, how many do we want? In part A, 0. And out of the 14 brown pieces, oops, how many do we want? 0. Well, remember what we did last time? You have 20 objects on the ground. How many ways can you pick up none of them? 1. So 20 choose 0, 14 choose 0 are all 1. So it would not have affected the problem. Now, if you would, keep that in mind and try part B. Exactly 2 of them are orange. But remember, you're still picking up 6 pieces, but only 2 of them are allowed to be orange. So a little hint, if 2 of them are orange, then the other 4 have to not be orange. So you want 2 orange and 4 not orange. Implied. How many orange are there? 20. Out of those 20, how many do we want? 2. So combination of 22. Is that okay? And how many are not orange? 32. Out of those 32, how many do we want? Good. Over, how many total pieces are there? 52. And how many are we taking? 6. Very good. So again, the numerator, of the 20 that are orange, we're picking 2. And of the 32 that are not orange, we're picking 4. Divided by, out of the 52 pieces, we're picking 6. Questions. The numerator, I got 6,832,400. Is that okay? And the denominator is that 20 million number. Now, before we continue, clearly, the proper way of eating Reese's Pieces are, you cut open the side of the bag, ha, ha, ha. You like do squirrel mouth, like store them in there, and then mill it down into a paste. Got weird there at the end. Yeah. You all know you've done it. I don't want to hear it. C. At most 2 are orange. There's that phrasing, at most 2. So 2 at most means less than or equal to 2. So anytime you hear greater than, less than, at most, at least, in terms of probabilities or events, you want to think about exactly. So it could be exactly 0 orange or exactly 1 orange or exactly 2 orange. So one more time, anytime you hear an inequality, at most, at least, less than, greater than, you want to rewrite it in terms of exactly. So at most 2 means you have exactly 0 orange, or you have exactly 1 orange, or you have exactly 2 orange. One more time? Correct. So each of these exactlies are going to be their own fraction, and the or means we're going to add them up. Good news. Part of part C is already done. Exactly 2 is what we did in part B. Out of the 20 orange, we're picking 2. And out of the 32 that are not orange, we're picking 4. Out of the 52, we're picking 6. But now it's going to get crazy, possibly up in here. So now we're going to do exactly 0. Let's do this together. So out of the 20 orange, how many do we want? In this case, exactly 0. 0. And out of the 32 that are not orange, how many do we want? 6. Divided by, out of the 52 candies, we're picking 6. Questions? Okay. What brave soul wants to tell me the exactly 1 numerator? No. Well, you can have 2 numbers there. So out of the 20 orange, we would want And out of the 32 that are not orange, we would want 5. Over, out of the 52 candies, we're picking 6. So anytime, again, you hear at most, at least, less than, greater than, rewrite it in terms of exactly's. And for each case, so these are the outcomes as we discussed, each case you find the individual probabilities and add them up. Now we could have written this as one huge fraction. And put it all over a combination of 52, 6. There's no way I'm going to fit this number. Oh my gosh. I got 11,766,112. Did anyone else get that? Or this 20 million number?